Modern enterprise software is built on a foundation of mathematical precision. When a complex system executes a task, we demand absolute predictability. We ensure that predictability through mature disciplines, continuous delivery, automated testing, quality assurance, and site reliability engineering. But the business rules that govern that software, the enterprise policies, are rarely managed with that same level of rigor. Most organizations rely on a fragmented process. It begins with static documents that are handed to analysts, translated into developer tickets, and eventually hand-coded into applications. These policies govern million-dollar healthcare eligibility decisions, complex tax determinations, and the operational boundaries of autonomous AI agents. In a landscape where regulations evolve constantly and deployment cycles are measured in days, policies cannot survive as passive documentation. To maintain reliability at this speed, organizations are moving policy logic out of documents and into the core system infrastructure. The trust we have in our software remains an illusion if the rules governing its behavior are still subject to manual interpretation and guesswork. Engineering is frequently confused with simple construction. In practice, the discipline is focused on producing reliable systems through analysis, modeling, and validation. Construction is only one part of the lifecycle. Policy engineering is the application of these principles to enterprise rules. It is the discipline of transforming human policy into reliable, testable, explainable, and deterministic software. This process ensures that the resulting executable logic preserves the intent, provenance, and governance of the original source document. The primary obstacle in legacy architecture is that business rules are hard-coded directly into individual applications. This creates a massive bottleneck. When a policy changes, every application node containing that logic must be manually updated and redeployed. To solve this, policy logic must be completely decoupled from the application code. We extract the internal logic blocks from the individual silos. This changes the role of the software. The application no longer interprets policy, it simply consumes it. The extracted logic unifies into a shared organizational capability, a centralized decision service that handles all rule execution. This allows the decision layer to be updated, tested, and versioned independently without interfering with the release cycles of the applications. By treating policies as centralized infrastructure, an organization ensures consistent decisions across every platform in the enterprise. This raises an operational question. How do we build a reliable decision service without returning to manual coding? The answer lies in a single principle. The human-readable policy document remains the only source of truth. The policy engineering lifecycle begins with the authoritative source document. We analyze and map its requirements just as we would for any other software project. Instead of writing code, the pipeline compiles policy directly from the text. The system generates tests to verify logic and cover edge cases. The output is a versioned API and decision trace, providing a clear path back to the authoring line. Just as developers maintain source code while compilers generate machine code, policy engineers maintain source documents, while the pipeline generates executable rules. Engineers do not trust a structure because it looks correct. They perform stress tests to identify invisible weaknesses. Business policy has its own structural weaknesses, ambiguities, undefined terms, and conflicting requirements. We expose these flaws using a diagnostic tool called wedge analysis. This tool maps the logic of the document until it finds exactly where the instructions break down. Wedge analysis does not guess at the author's intent. It identifies the contradiction and stops the pipeline, requiring an expert to resolve the issue before deployment. Artificial intelligence, specifically large language models, can significantly accelerate the interpretation of complex legal and business text during the analysis phase. However, there is a dangerous trend of embedding these LLMs directly into runtime applications to make decisions on the fly. Using AI at runtime destroys governance. Because LLMs are non-deterministic, they can hallucinate or produce inconsistent results that cannot be accurately traced. Policy engineering enforces a strict boundary. AI is used for engineering and compilation, but never for execution. AI extracts the logic from the text, but that logic is locked into rigid mathematical rules before it ever reaches production. There is zero AI at runtime. This is the only way to utilize the semantic power of LLMs while guaranteeing 100% explainability and determinism. Every major shift in computing has required a new engineering discipline to manage the resulting complexity. We have seen this progression from software and data engineering to site reliability and AI engineering. Policy engineering is the next stage, synthesizing expertise from law, architecture, compliance, and DevOps. In an era where AI participates in software creation, treating policy as static documentation is a liability. It must be engineered. Sertainly is the platform built to execute the complete policy engineering lifecycle. It transforms raw source documents into tested, versioned, and explainable decision services. Every decision is compiled, deterministic, and fully traceable back to the source. Policy has always governed the enterprise. Sertainly provides the tools to manage those roles with the same rigor we bring to the code itself.